domain. Domain in the sense, domain might be of what was happening. Domain in the sense
Ma'am,
might.
when recording starts, automatically some student get disconnected.
Is it?
It's the
Why?
problem. It's the problem of Google Meet.
I have never faced it. First time I am listening this thing. Now they are joining their writing, huh? Okay, they will join. So let's start with the questions. What kind of questions would be there? Yeah, everybody write down. If n is the set of all natural numbers. So first of all, you should know what is the natural number. What are the natural numbers? Positive integers.
1, 2, 3, 4.
Positive integers excluding 0, right, are the natural numbers 1, 2, 3, 4, 5. Then if n, capital N is the set of natural numbers and f is defined over this set n such that fx equals to x square, then
This question we have done, ma'am.
done. That's why I was asking you now, people. Okay, I think I had given you for real numbers. Okay, to do for real numbers. This is done. Okay, fine. I change the question. Just tell me quickly whether that is done or not, instead of wasting the time. That fx equals to 5x cube minus 1. This one. Hmm? Is this done, this question?
No, ma'am.
Okay. Okay, so write down. If f is the function from R to R, means real number. Okay. Defined by fx equals to 5x cube minus 1. Then show that f is 1, 1 and onto. This type of problems are not done in this class. Then show that f is 1, 1 and onto. So first you need to understand the concept. Such kind of question where they're asking 1, 1 and onto, how to prove that. So first of all, you will take one by one point. First is 1, 1 and another one is onto. So when you are talking about 1, 1, 1, 1 means what? If two different elements are there. This thing also I think I have explained in the previous session, but again I repeat. If two different elements are there, then their images must be different. Because if the images are same, then we say many to one, right? So when you are such kind of question, you say then prove that it is a function with 1, 1 and onto. Then first of all, for 1, 1, what you will say, let x1 is not equals to x2. Some two different elements you have taken. Now these are two different elements. So even if I take, their cube will be different. If I multiply with 5, that will also be different. And if I subtract 1, that would also be different. Why I am doing all this? I am trying to convert it as the fx. Okay. Now what you see, this is what fx1 is not equals to fx2. Means for different elements, you had different images. Right? So hence f is 1, 1. This is a fixed pattern. For any kind of problem, if you see that you are supposed to check whether this is 1, 1 on 2 or not. If suppose not, then you need to give counter example. If it is 1, 1, then you need to take two different elements, check their images are different or not. Okay. For onto means what? First the concept should be clear. Onto means in the range, each element should have pre-image. So means let I am taking any element in range. This, for example, this is A set, this is B set. Now I am taking element of B. So let y belonging to R. Although I need to show because R to R. So let y belonging to R such that this y is would be equal to this. Now convert everything in the terms of y. Take everything here. Y plus 1 by 5 and x equals to y plus 1 by 5 by 1 by 3. Means that is for each y, belonging to codomain, there exists X in domain. Hence, it is onto. The conclusive statement will be, yeah, the function is, given function is 1, 1 and onto. Any doubt, please ask. Means see, we had taken y, and for that particular y, we had got some value x, right? So whatever the value of y, there would be some x. So that's why we are telling that this is onto function. Any doubt, please ask. Am I connected? I keep on speaking. I am connected. When you feel not to speak, then you speak. Till then, I am sitting simply. What happened? Say, clear or not?
Yes, ma'am.
Yes, ma'am.
Clear, ma'am?
Yes,
Yes,
ma'am.
ma'am.
Second problem. Same problem, f is defined r over to r such that fx equals to x cube. So determine whether f is invertible, and if yes, this is done, I think. Is this done? Fx equals to x cube?
No, ma'am.
No, okay. Then the question is determine whether f is invertible, and if yes, determine f inverse. For invertible, we need to check this is 1, 1 onto it is or not. Okay, if it is not, then definitely it's not invertible. So for 1, 1, let you will be taking some 2 different element. So if you are taking 2 different elements, their cube will also be different. I can't say this thing for square. Remember this thing, because square of positive and negative is same only. So I can say simply, if suppose in case here it's a square, we have done such kind of problem already also. In case of square, we can't do that it is unequal. 2 different elements square is unequal. No, 2 different elements can have same square, positive and negative numbers. But for cube, it's always different. For negative, it's negative. For positive, it's positive. So implies fx1 is not equal to fx2. So different elements have different images, hence 1, 1. Okay. Now for onto, let same you will be doing some y element is there such that this y will be in the form of this. So x will be y raised to power 1 by 3. Hence onto means for any y there will be some x like this. Okay. Now the question was whether the function is invertible or not. Since this is 1, 1 and onto, hence function is invertible. Then the next question was find its inverse. Then inverse. Inverse means we had got already, you have seen that inverse you were taking f inverse y. Okay, so if I write, I can write this was what actually y was actually equals to x cube, and this is actually just symbolic representation. If you see any element, if I am taking in codomain, it's a y cube only, not y. Okay, here we have written y equals to x cube, so that is same only y cube. For this y cube, I need some x value here. So I can write directly here only. Don't get confused. Just put x raised to power 1 by 3. This is actually, if you see here, if I'm putting x equals to y cube, so y will be x raised to power 1 by 3, right? The same here. Fx actually, fx equals to, the f inverse y will be x raised to power 1 by 3. This is it. This question have come January 19. Write down. And the last question in the previous session, which I had given for x square, that had come in June 19. Any doubt, please ask. Next problem. Let again n be the set of natural numbers including 0. They are telling specially specified including 0. Okay. Determine which of the following functions are 1 to 1 or onto and which are 1 to 1 onto both. Okay. Two functions simultaneously they are giving and they are asking whether these functions are 1 1 or onto or both. Okay. So where first is fx equals to x square plus 2 and b second is fx equals to you people only will discuss. I am not going to do this. If x is odd and if x is even. Tell me for first function this. Tell me, is this 1 1?
Yes, ma'am, it is 1.
It is 1 1.
Yes, ma'am.
Why? What if I put negative value?
All are natural
Correct.
numbers.
Correct. Onto?
It's not onto because some of the images will not.
Right. Because less than 2, you can say like 0 or 1
Yes, ma'am.
won't be having pre-images. So not onto. Easy. 0 and 1 don't have pre-images. Although many numbers are there. I am taking just simply, you can see less than 2 numbers because the minimum number x you put 0 of natural number 0. So you will be getting maximum 2 in the range. While in that codomain 0 and 1 are also there. So don't have pre-images. So not onto. Very good. Second part, other than Shivansh. This was Shivansh, right? Who had given this answer?
Yes, ma'am.
Okay, now Shivansh, you quiet. Yeah, others who want to speak. Let's discuss with this function fx equals to 1 and 0. Tell me whether it's 1 1 on 2 or not. What happens? Susan, Pranav, Preetam, Soumya, all are absent. All are absent, is it? Susan, I saw. I think Susan, you were there. Susan.
It's not 1 to 1, ma'am.
Then say na, speak. First tell me, it is 1 1? Is it
No,
1
ma'am.
1? Huh?
No, ma'am.
Why no?
Ma'am, because there is only 1 and 0, no, ma'am. So if it is odd, it is 1. If it is not, if it is even, it is 0, no, ma'am. So it is not 1 to 1.
Correct. Means for all odd numbers 1, 3, 5, 7, all are having image as 1, and all odd even numbers like 2, 4, 6, 0 in fact are having 0 image. So this is not 1 1. Correct. Onto the for sure it is not, because it is having 2 images only 1 0. What are the 2, 3, 4, 5, 6, 7, 8, 9, 10 other elements? So not onto.
So both are not.
Because only 2 elements are image, or you can say having pre-image, others are not having any pre-image. So it is not onto. So clear this thing, 1 1 and onto. Last question I'm taking of this 1 1 and onto thing. And then we will move to the pigeonhole principle. Let f is there, r to r. This is a combination of composition function and invertible function. So let f is r to r and g is some another function from r to r. Find, first question is find FOG and GOF, where fx equals to x square and gx equals to x plus 4. Okay, so first question is composition of functions. Now second question starts, state whether these functions are injective surjective or bijective. Okay, so these functions, what is there? So don't start doing this for fx and gx. They are talking about fog and gof. These are one on two or both. These are or not. Okay. So first of all, tell me quickly what will be the fog.
X
Girls.
square plus
X
4.
cube
Now I
plus
want
4.
answer from the
X,
girls.
X
FOG.
square plus
Tell me. FOG.
X square plus 4, ma'am.
FOG. Okay. And GUF? Hmm?
X
X
plus
plus
4
4
whole square.
whole square.
This is x plus 4 whole square, huh? Both
Ma'am,
are.
ma'am, f of c is x plus 4 the whole square, ma'am.
What are you doing, girls, huh? Only boys are responding. FOG will
Ma'am,
be x plus
GOF is x square plus 4 and FOG is x plus 4 whole square.
yeah. Okay. Now we will discuss for first we will take FOG and second we will take for GOF. So you people only tell me whether these are 1 on 2 or not. Both. For FOG, tell me 1 on 2 and for GOF. For FOG, first discuss with this. Is it 1
Not
1 or
1 1.
2? 1 1?
No, ma'am.
It's not 1 1. Hmm? Why?
It has got negative value and
Same.
of
Again,
negative
it's a
square
square.
is also
Same
20
only. So if it's a square, so even if we put the value of x like, for example, -2 and x value is -6, both will give the same answer. Counter example we need to give, right? Means if this x plus 4 is whether positive or negative, but same number, then square will give same. So not 1 1. On to? On to? Is it on to? Is it?
No, ma'am, it will not be on 2.
It won't be on to?
No,
Why?
ma'am. Because x square putting as -1, we will get image will not be
Here.
pre-image will not be
Oh, FOG we are talking about. FOG.
x plus 4.
It won't be, ma'am.
It won't be, but why? I agree. I'm not telling it's wrong. I'm asking you why.
First find x in terms of y, ma'am. Then we'll get an under root y.
Right.
If we are putting negative in that, it won't be real number. X equal to under root y minus 4 will come. So
It will give
value
an imaginary number, no?
Sorry?
It will give an imaginary number.
Actually, your answer is correct, but approach is wrong. Approach is little wrong. It's not about the imaginary number. Imaginary number thing will come here in this, but not here.
domain and codomain is for R to R, no, ma'am. But imaginary
Because
number.
you can say directly for on to. So if you take like for example 3, or you can say like 5, these don't have pre-image. See, this is a square, so only the perfect square numbers will be having pre-images. See, if I put x value, anything if I'm putting, anything, I will be getting a square, for example, 2 or For example, 2, 4, 8, anything. But like 3, 5, these numbers are not having any pre-image. So that's why. And that imaginary thing you are saying would be applied here for GOF. Okay, so here you can say the number which are perfect square having pre-image, but the numbers which are not perfect square will not be having pre-image. Okay, so that's why not onto. Now let's discuss with GOF. Tell me. It is the same, like concept is same of for this also. GOF is x square plus 4. Let's talk about it. Is it 1, 1?
No.
No. Why? Because same thing. For positive or negative, if you put, you will get the same value. Okay, onto. Now it would be that logic. Is that of x is equals to plus minus square root of y minus 4. Or I should write actually y is equals to x square plus 4 x y minus 4, correct only, right? So now you can see here for y is equals to 1, 0, 2 and 3, we will not be having any pre-image. Actually, we could say here also, sorry. Here also the same thing applied. You were correct actually. If I'm taking x plus 4 whole square, then x is equals to plus minus square root of y minus 4. Here also we could say for negative value of y. Correct. That is correct logic. That is also correct logic. Both are having same logic because it is under square root and set is a real number. I forgot actually we are talking about real numbers. Right. So for real numbers, even negative numbers are there. So we will be getting complex number and that's why they don't have any pre-image. Correct. So these both are not 1, 1 and onto. If both are not 1, 1 onto, then forget the bijective. Okay. So any doubt in this 1, 1 onto things, please ask. Otherwise, I am wrapping up. 3 sessions I have delivered only on this 1, 1 onto and invertible. Any doubt, please go ahead. Tell me.
No, ma'am, no doubt.
No, ma'am.
No, ma'am.
Then next topic that is very important I'm taking now is pigeonhole principle. Although this thing we have already discussed in this second module when we were doing combinations with repetitions. So that is kind of same thing, okay? This pigeonhole principle. What it states that, for example, I will talk later about in the term of pigeons, first in general, okay? Let I am giving you 4 rings, okay, to drop in 3 boxes. Okay, so one box is there, second box is there, third box is there, and I'm asking you to put 4 rings. So 4 rings you are putting, there are a lot of probabilities that all 4 rings you are putting here, all 4 rings you are putting, or might be 3 here, 1 here. But even though if you want to occupy each box, first put, second put, third put, what about the fourth? Fourth will go again in some of the any of the block. It will be completely your choice whether you want to put here, you here, and so I need to put here, for example. So it says if more objects we want to fit in the less space, then definitely at least one space will be there which is having more than one object. It's practically, obviously, right? So let's talk about particularly for pigeonhole principle. It says for it talks about the pigeons. So objects like here I have done ring, so they call them pigeon. Okay, and the places like boxes I have taken, they call them pigeonholes. So this theory says, so if, for example, if you are having 5 pigeons, but for 4 holes, holes means might be in the net, sometimes hunters keep, right, to catch the pigeons. So let, for example, we are assuming that all are having different holes. But again, 5th pigeon will have to be come under any of them. There is not necessarily that all are, might be this is left empty. There is a probability. In fact, this was also probability. But at least what is there? So at least means we are assuming they are trying to occupy all places. In that case, at least one pigeonhole would be there which is having more than 2 pigeons inside it. Obvious, no? So any doubt in that? So this is the pigeonhole principle, which talks about particularly pigeon and pigeonholes. Okay. Now the question is this thing that I have taken. If you see here, just only one thing extra. This is 4 in 3, 5 in 4, but it's not necessary always, right? It could have been here, for example, 50. Okay, so 50 pigeons and 4 pigeonholes. Then to find then that even though if you want to repeat 6, 7, 8, 9, 10, 11, like this, you are distributing the pigeons. Okay, then what is the at least number of pigeons in one pigeonhole, means minimum number, would be equal to, that is denoted by P plus 1. Now what is this P? P in nothing, just M minus 1 by N. This I will tell you what are these M and N things. This will be the formula you need to remember. That is P is M minus 1 by N. It says. So means here I would apply this formula here and I would show you. I would show you how to do this. Okay. Now, what for the question comes first? What is M? What is N? M is here number of pigeons, and N is here number of pigeonholes. Okay. So first, by the question only, you will understand that the objects which we are going to shift are pigeons, and the places where we are shifting them are the pigeonholes. But second thing, in roughly, I'm telling you, the larger number you see, you put it as M, and the smaller number you see, put it as N. Okay, sometimes students get confused what is pigeon, what is pigeonhole. Then simply bigger number is M, where M is greater than N. And the theory and the whole theory you can find in the notes. So I'm not explaining, I'm not dictating the pigeonhole principle, I'm giving you the concept. So let's start with this. Like this only random example I have taken, that 50 pigeons in 4 pigeonholes. So I need to take M as 50 and as 4. Then P will be, now this thing also I need to explain to what is this. I'm not putting bracket. First tell me, I'm not putting this. I am putting here. And one is there here. Do you know what are these? These are some functions. Do you know what are these? This is the simple 1.4, right? This is called ceiling function. And this is called floor function. As you can see, this is on top. So this is ceiling. It's behaving like ceiling, and it's on the bottom. So that's why floor. Okay. So what we do, it's like rounding off the number. But till now, what we have studied rounding off. If it is less than 0.5, we take the previous number. If it is more than 0.5, we take the next number, isn't it? Like 1.75, round off 2. But if I take 1.4, round off 1. But here, this floor doesn't talk about any limit, 0.5. It says simply, if you are taking floor, it will be the previous integer, that is 1. And if it's a ceiling, would be the next integer. So it doesn't matter, even though if I am having 1.1 ceiling. So here I should not be rounding off to just 0.1 now. Okay, I should take 1. But if it is ceiling is there, then I should take the next integer, that is 2. Okay, and if it is, for example, it is 1.9, even though I will have to take floor means 1. Clear this thing? These are the two functions, floor functions, ceiling functions. Clear? Any doubt in these? How to do? If it is a complete number, then no issue. If, for example, 2, then obviously it would be equal to integer. Ultimately, we need an integer. Okay. Any doubt in this? What is floor and ceiling?
Ma'am, in formula, what we will apply, the floor
That
one
I'm
or the
going to.
ceiling one?
Just first I was explaining this. Okay. Now I will apply here. Ceiling or floor only we will apply in the formula. 50 minus 1 by 4. Let's calculate it. 49 by 4. Just tell me quickly how much it is. It will come in decimal. 2.25, I think. Yeah. So P will be floor. This floor. So I need to take 12. So the question would be, so like I ask you that at least one pigeonhole will be having at least how many number of pigeons? Okay, at least. It can be more than that. It can be more than that. Means if suppose all are sitting in one pigeonhole only, but we are taking that all are trying to take different positions. In that case, so at least number of pigeons will be P plus 1. You won't leave here P only. P plus 1, that is 13. Okay, now I tell you practically how to do this. See, I was telling you 50 pigeons and out of 4 holes. Okay, so directly if you divide 50 by 4, what you're getting? 12?
12.5.
12 integer we are talking about, because pigeons you can't take half. You can't cut them. Bleeding is not allowed. Okay, so 12. 2 are left. So 12 will be distributed equally. Means I should say out of 4, 3 have been occupied. Now 2 are left. 3 have come, 3 have come, 3 have come, 3 have come. Only 2 are left. Only when 2 are left, because if you see, no. I should say 12. Why I am telling 12, 3. 12. I should draw different here. See, 12 pigeons are here, 12 pigeons are here, 12 pigeons are here, 12 pigeons are here. So it is 48. But 2 are left. For 2 also again coming, this is 48. So 49 is suppose coming here, 50 is suppose coming here. So minimum at least. So if you see, at least any of the pigeonhole will be having 13 number. So that's why 13.
Ma'am, can't it be any of the pigeonhole will be 14? Both the remaining pigeon in one hole only?
Sorry, not getting. Come again. What are you saying?
Ma'am, if we put both the remaining pigeon in one hole only, then it could.
That is the word is there, at least number of pigeons. It can be. We can put that 50 number here only. But we are using at least. If we are trying to occupy each box, otherwise many probabilities are there. Like that we have studied in combination with repetition. Was this only? Means there is, what's the probability? It's not necessary all are having 12. It could have been like here I put 10 in fact, and other 2 also I put here. What it was, 48th number and 47th number also I put here. Lot of combination permutations are there possible, but we are saying this will the for sure will be there. Like we say na, sometimes for sure it would be. So at least one pigeonhole will be having definitely 13 pigeonholes. So pigeonhole will be having one pigeonhole must be having at least 13 pigeons. More than that is possible. Many cases are there. Then we talk about permutations or combination with repetitions. But we are talking here at least. What are the chances that at least repetition chances? You can say like this. The repetition chances are there. Understood?
Ma'am, at least so it can be 0 also, na? Like 12 pigeon go to only one hole.
Oh, you are taking only at least number of pigeons. The whole statement is this. Must contain. Actually, I should write the full sentence like this. One pigeonhole must contain at least number of pigeons. You are not understanding actually. You are saying 0 could be there, right? You are taking like this.
Yes, ma'am.
If I shift these all 12 here and I put it 0. So you are taking least number of pigeons. We are not saying this thing. Actually, the sentence is going in this way. You are thinking like this way. Okay, when you do one thing, I'm dictating one sentence, you write in your notebook, then you will understand. I'm dictating one sentence, just note down. I'm trying to dictate it. If M pigeons occupy N pigeonholes, if M pigeons occupy N pigeonholes and M is greater than N. One condition is there that M is greater than N. Then two or more pigeons occupy the same pigeonhole. Then two or more pigeons occupy the same pigeonhole. And then at least one pigeonhole must contain two or more pigeons in it. Then at least one pigeonhole must contain two or more pigeons in it. Now read this line and then tell me what you are getting. They are not talking about at least number of pigeons. They are saying at least one pigeonhole would be there. See, for example, 5 pigeons I am putting here, 6 pigeons I am putting here, 13 I am putting here. These are the blanks. Blank, blank, blank. Try to understand. I am trying to explain it more. We are not counting which pigeonhole is having the least number of pigeons. If the question is which pigeonhole is having least number of pigeons, then we say these. That is 0, 0, 0. But the question is, you can say the theory says that one pigeonhole must be there. How many these are there? If you tell them 13 plus 6, 19 plus 5, 24. Total of 24. This theory says that in this particularly I'm talking about, in this there is means two statement, not theory actually, two statement I'm trying to make the differentiate. First statement I'm saying find pigeonhole having least number of pigeons. Okay, this is first statement. Second statement, one pigeonhole is there which is having at least p plus 1 number of pigeons. So try to read these two lines and try to make the differentiate. And then tell me where you are confused. First tell me, these two are having, this PH I have written for pigeonhole, short form. First tell me, is there difference between these two lines? First I'm telling pigeonholes having least number of pigeons. So having least number of pigeons means then you will see the number of pigeons. Here it's 5, it's 6, it's 13, and here it is 0, 0, 0. So in the first case, I will be writing these 3 pigeonholes. This, and this. But the second statement is telling out of these 6 pigeonholes, one pigeonhole must be there which is having at least p plus 1 number of pigeons.
Yes, ma'am. Now I understood.
Sure? Clear?
Yes, ma'am.
So this
Yes,
thing
ma'am.
was not about which is having least number of pigeons. It was not about that. It was saying whatever or how much ever we try, even though that distributing evenly, everything evenly, if we want to distribute even though, but some place will be there which will be shared definitely. And that will be shared by minimum number possible. Minimum possible numbers. Okay, more than is possible. Means here, like he had given you example. So it was a choice that it could have 24. But there is, again, we have read already permutations there, that if we want to shift the things. But the question is, we are finding any pigeonhole must be having at least these many numbers of pigeons. Okay, so this is that's why there is a difference between these two statements. Don't take it least number of pigeons. This is one pigeonhole must be there. Okay, any other doubt? I think Shivansh, you were having some doubt.
Clear, ma'am.
Clear? Sure.
Yes, ma'am.
Then I take the problems based on them. Very easy problems are there. Let's start with this. And but interesting. Prove that if, everybody note down, prove that if 30 dictionaries in a library, prove that if 30 dictionaries in a library contain a total number of 61,327 pages. 61,327 pages, then at least one of dictionaries must have at least 2045 pages. Now understood this question? See again, there was a probability that in one dictionary all pages are there and others are blank. Okay, but they are telling okay, what can be once we do first evenly distribution, and even though what is the minimum chances that the 30 dictionaries and having 61,327 pages, we need to show that at least one of the dictionary would be there, must have at least 2045 pages. So actually, this thing, you understand, like practically, this they have made more complicated. Otherwise, simply what can we do? Directly you divide it by this. Then you will find evenly it is distributed.
Divide pages divided by number of dictionaries.
Right. You will be dividing this, so not by this actually, sorry, number of dictionaries. Okay. So you will up to the integers, like we have done, right? Up to the integers only.
2044 pages.
20, you divided it, did you get? Or simply you are telling?
Yeah.
Have you done this?
2044.
20445 multiply by this means what you will do, roughly I'm telling you, is thoda sa I am going little side of this pigeonhole. In general, practically, if I ask you, divide these pages equally to all dictionaries and how many are left, then what would you do? Simply, you will divide this number out of 30, then you will be getting some even numbers. Like, I don't know, but Shivansh is telling 2044, some integers. Okay. So 2044 is equally distributed in this. Multiply by 30. How much it is? This one, I think, Okay. So here 61,320 are distributed evenly. Okay. Now the remaining 7 pages you will be doing here 31 out of 30 dictionaries. So ultimately you will be taking the one number more. That's it actually. That's why I'm taking this pigeonhole principle. I feel my mother generally they have just made it simple thing into complicated. But actually what happens now? We are studying only basic things. These theorems and principles have broad applications, but here these are not, so that's why we are not understanding. So let's start with, we don't discuss anything extra. Let's come back to the topic. The topic was, we need to discuss it with the pigeonhole principle. We need to understand, they are telling that these are the pages, 61,327 pages, and they want to, these pages will be definitely in dictionaries. Dictionaries are less, so will be number 61,327 are the pages, and these pages are inside the dictionaries. So we need to check that one of the dictionary will be having how many pages. So let's start with the formula. So 61, 327 minus 30 divided by, what I'm doing, minus 1 divided by 30 plus 1. So it would be 61, 326 divided by 30 plus 1. This number was 2, tell me the complete number from your this calculator. 2044.25,
2.2.
okay, plus 1. The floor function, it would be 2044 plus 1, that is 2045, proved. Hence, one dictionary, at least one dictionary would be there, which will be having at least 2045 pages. More than that is possible, but at least, even though if we equally distribute the number of pages, one dictionary would be there at least, which is having 2045 pages. This is the theory of pigeonhole principle. Any doubt? Please go ahead. Please ask. Next problem. This type of problem will come like I am taking now. If 8 children are born, if 8 children are born in the same week, in a week 8 children are born, then prove that, two or more children are born on the same day of the week. Then prove that 2 or more children are born on the same day of the week. See, practically if you think, in a week we know how many days are there? 7, right? So even though if we assume that one child is getting born on Sunday, Monday, Tuesday, Wednesday, like this, so 7 children can occupy 7 days, right? Although it's not possible, means like we can't fix it that all kid is getting born on the different day. But if in case we assume that all are born on different days, so from Sunday to Saturday 7 are born, then but this is that in the same week they are putting. So don't say ma'am next Sunday 8 children will be born. They are telling in the same week 8 children are born. So the 8th child will be born again, will be repeated. Some of the day would be repeated definitely. So in one of the day, it must at least 2 children are born. So in practical thing, but again we need to do by pigeonhole principle. So here, what would you see that 8 children are there which are born in 7 days because in same week. Okay, so we need to find out that at least in one day how many children are born. So let's start with this formula again. M minus 1 by n plus 1, that is 8 minus 1 by 7 plus 1. 7 by 7, 1 plus 1, that is 2. Hence proved. So this was the at least number actually. So that's why in the question it is 2 or more, means 2 or more. Okay, are born on the same day of the week. So this is the problem, and same kind of problem I am giving you for homework. Prove that in any set of 29 persons, prove that in any set of 29 persons, at least 5 persons must have been born on same day of the week. Okay, you will do now. It also simple, same thing, just difference is here 8 children were there, here it is 29 persons. Otherwise everything else is same. These are also talking about same day of the week. This was also the same day of the week. So here M will be 29 and will be you will be putting 7 because in a week there are 7 days. M is 29 and will be 7. Solve it, put like this here only. So 29 minus 1 will be 28 by 7, 4, 4 plus 1, 5. Proved. Orally only done. Okay. Now little different question. Any doubt? That time only you stop me, okay? Find the least number of ways. Everybody write down. Find the least number of ways of choosing 3 different numbers from 1 to 10 so that all the choices have the same sum. Sum means addition. 3 different numbers we need to choose from 1 to 10 so that all the choices have same sum. And that is also least number of ways. Least number of ways of choosing. Okay. So let's start with first we need to identify. See what is this mean? 3 different numbers from 1 to 10 means we can make a lot of pairs like 1 2 3. I'm choosing 135. I'm choosing 167. I'm choosing 246, 238. But different. Repetition is not allowed. Different. 4 5 6. Right? Many possible. So first we need to find out the total possible number of choosing 3 numbers from 1 to 10. Tell me, out of 10 numbers, I want to pick any 3 numbers. What will be the formula? All of you know this. Correct.
10C3.
Because I am not giving any order. I am not asking you to put in particular order. Just randomly, you are choosing any 3 numbers. Out of 10 is 10C3. Okay. What would we do? 10 into 9 into 8. And 7 is 3 into 2 into 1. It would be 30 into 4, 120. So this is the total number of possible, like I given you example, 156, I'm putting 178, I'm taking 1358 or 268, any number. So there are possible number of pairs of 333 numbers is 120 combinations. So we are having 120. Now we come to the question. What was the question? Choices have the same sum. See, they are asking any 3 numbers you are taking and you are finding their sum. Sum is addition. So we will see this sum. What are the possible sums? So we out in 120, it's like kind of impossible to find out that. So what would we do? We will check first what is the possible least sum and what is the possible highest sum. So possible least sum and one I will take possible highest sum. How can we find out that? See, least sum in the sense, least sum when we can get if we are choosing 3 least numbers, right? So means if we choose 1, 2, 3, we will be getting the least sum. If you change any number, you will be getting higher sum only. We check it. If I check, obviously, addition is there. Okay, and highest, if you choose the highest number, that is 8, 9, 10. So this thing we have understood that any combination we are picking up out of 120 will be having sum from 6 to 27, not less than 6, not more than 27. It's not possible. Any combination you pick up from 1 to 10, your choice for if you want to cross verify, any 3 numbers you pick up from 1 to 10 and check their sum. Addition. That sum would be lying definitely from 6 to 27, including 6, including 27. Okay. Now they are asking what is the least number of ways? Least number of ways of choosing. See, like 24, for example, 24. So there would be different combinations. Might be 4, 9, not 4 actually. If I put 5 plus 9, 14 plus 10. This is a combination of 24. And if I do 6 plus 9 or I say 7. Yeah, this is also 24. Huh? So there would be number of, just to, here I have made only 2 combinations. So you can see each sum is having lot of number of possible combinations. It was 5, 9, 10, 7, 8, 9 also was having giving the sum 24. Many will be there. If you keep on increasing this number, keep on reducing this number, you will be getting, right? The possible number of 24 random number I have picked up. The same 6 to 27 you are having total. From 6 to 27, how many numbers you are, some are there? 22. From 6 to 27 are 22, including them. Yeah, including them, there are 22 sums from 6 to 27. Okay, so such a kind of sums we are getting, or by making of it, they are asking how many possible number of ways, at least not many, actually least number of ways of choosing combinations. Okay, least number, at least number. So in such case, when you see, we will be seeing that M is 120. The total number of ways are 120. We can choose 3 number combinations is 120, and that is giving out of from this sum to this sum is minimum. Such numbers are 22. So the line will be, hence the least number of ways of choosing the choices have the same sum will be p plus 1. That is m minus 1 by n plus 1. Put the values, 120 minus 1 by 22 plus 1. 119 by 22 plus 1. How much this is? This is how much? Should I use my calculator or you would tell? Hmm?
6.409.
6.
5.4.
5.4 it is, 5, that is 5, and 5 plus 1, that is 6. So means the least number of ways means when we are choosing 333 combination, then the least would be 6 which are having same sum. Like I have written 24, for example, the given 24. So definitely it would be having more than 6 numbers. 6 combination, not numbers actually, 6 combinations. 23 if I pick. So this will also be having minimum 6 or more than 6. So like this is the question. The same sum, there are same sum which are giving same sum for particular sum. How many combinations are possible? So total number of possible ways are 6. Okay. This was the question. Although will not come, I know this will not come, but this was important. Nice question it was. Okay. Any doubt up here?
Ma'am, I didn't understand how you got 22, ma'am. N is equal to 22. That one, can you explain, ma'am?
This was least sum 6. This was highest sum 27. Count the numbers from 6 to 27. Including 6. Count.
Understood.
22.
Yes, ma'am.
That is. Okay. Okay. Anything else you want to ask? Others? Then one more problem was there. Here it is. Then the last problem of pigeonhole principle. Important. This only comes, which I am taking now. This either or that birth thing. Okay, birthday on the same day or the week. Okay. Now the question is, everybody write down. ABC is an equilateral triangle. Equilateral means all sides are equal.
All sides are equal.
ABC is an equilateral triangle whose sides are of length 1 centimeter each. Okay, equal है तो 1 centimeter, 1 centimeter, 1 centimeter each. If we select 5 points inside the triangle, if we select 5 points inside the triangle, prove that at least 2 of these prove that at least two of these points are such that at least two of these points are such that the distance between them is less than half centimeter. Prove that at least two of these points are such that the distance between them is less than half centimeter. This is the question, important question. Okay. See what they are saying. One equilateral triangle you are having A, B, C of 1 centimeter each. Okay. They are saying put 5 points inside this. Far it's possible we are putting these 5. Okay. Then there is possible that we are putting 5 points farthest or equal. Then 2 would be there. Even if we try 4, we can put, means 4 we can put the maximum distance, but the 5th one would become definitely near to some another point. And near in the sense that distance between 2 would be less than 1/2 centimeter. Means this is very small triangle I put here. For example, 3 and 4. These 4 points I have put which are having greater than half centimeter distance. Okay, where distance is greater than half centimeter. It can be 0.75 or anything. Okay, but they are telling if we want to put any 5th point, then this 5th point we can't put such that its distance is also greater than half centimeter. Definitely this would be near to the sum of any other point that its distance would be less than 1/2 centimeter. So that's why the question is prove that at least two of any of these points are such that the distance between them is less than half centimeter. It means it's not possible to put all 5 points equidistance which is more than half centimeter. You understand like this. Okay, for an equilateral triangle of 1 centimeter each. This is the question. Understood this thing? Now let's start it. How to solve it? What would we do in this case? I make another triangle little bigger and clear. What would you do? First, you would put midpoint, exact midpoint, because like it's a half centimeter. So exact midpoint we are going to put and join them. So another triangle you will be getting. You see now 1, 2, 3, 4. One greater triangle was there, bigger triangle, and inside that 4 small triangles are there. So means how I told if we will try to put the points as far as possible. So even if we try, 4 are being possibly far, right? But 5th point, again 5th point I need to keep, it's same like working like a pigeons and pigeonholes. So 5th point I need to put somewhere inside repeating. So anyway, it's completely your choice. You can show here, or there. So for example, I am putting it here. Okay, although I will dictate the theory, this question is completely written as a theory, but you should understand like this. So here you can see M was 5 and N was 4. Possible number of triangles were 4. So P plus 1 was M minus 1y. Why I am putting 4 directly? N plus 1. Actually, it's not showing distance by this formula. So that's why I need to explain in theory. 5 minus 4y. Why I forget? This is 5 minus 1. Y 4 plus 1, that is 2. Okay, so it's showing that 2 point will be, that one of the triangle will be having definitely, one of the small triangle will be having definitely 2 points at least. It is possible that 3 points are there, but at least 2 will be there. Now the question is, how can we say that these are having less than half centimeter? That I tell you. See, when we have drawn these midpoints, so that
Ma'am, could you explain once again how n equal to 4?
N equals to 4. When we draw these triangles, means you can say big triangle, I have divided in smaller equilateral triangle. Then the possible thing is I can do is dividing by like this. By taking midpoint of the sides, take the midpoint of the sides, join them, you will be getting 4 small triangle, ADF, DBE, DEF, and this FEC. 4 triangles you can see. So that's why N is 4. And in these 4 triangles, we can put these 5 points. Okay, just to have an idea, if you don't draw this, what happens here when you draw the points, you want to not getting exactly the location and the distance between them. But if we are drawing these, so we know that these are equilateral triangle. All are having, this is also half centimeter, this is also half centimeter, this is also half, this is also half, this is also half, this is also half. So the maximum distance we can make between 2 points will be if we put the 2 points in 2 different triangles. So then that time we can make the possible maximum distance between them. Okay, so for that purpose we are making small triangles. Understood now? So for that purpose you are having 4 smaller triangular. So that's why n equal to 4 from there. But here we got only that one triangle is having 2 points. At least one triangle would be there which is having 2 points. But the distance between 2 points, see, in a triangle which is having all sides half, 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 and half, then inside 2 points are there, definitely their distance would be less than half centimeter. Okay, this is the conceptual. But now I dictate the theory. Please everybody write down of this problem. This is completely done in the theory only. So please write down. Let we have a triangle ABC. Let we have an equilateral triangle. Let have an equilateral triangle ABC of length 1 centimeter each. Then we take the midpoints. Then we take the midpoints on each side of the triangle. By taking midpoints on each side of the triangle, and by joining them, one another triangle DEF is formed, and by joining them another triangle DEF, capital, everything should be in capital, DEF is formed. Now we observe that triangle ABC is partitioned into 4 small equilateral triangles. 4 small equilateral triangles, each of which has sides equal to 1/2 centimeter. Sides equal to 1/2 centimeter. Now if we put 5 points inside these triangles, now if we put 5 points inside these triangles, we see that pigeonhole principle can be applied. We see that pigeonhole principle can be applied by assuming, people are writing or am I dictating simply?
Writing, ma'am.
Okay, fine. We can apply
The
pigeon.
writing.
Okay, fine. Pigeonhole principle can be applied by assuming points as pigeons, points as pigeons, and small triangles as pigeonholes, and small triangles as pigeonholes. And evidently, at least one small triangle, at least, and evidently, at least one small triangle at least one small triangle will be having 2 points, such that the distance between them is less than 1/2 centimeter. Okay, clear or doubt?
Clear, ma'am.
Okay. Okay, this was the pigeonhole principle. Any doubt in the whole? Then you can ask. Otherwise, this is done, pigeonhole principle. Then I will move to the next topic. And if you want to ask anything, you can go ahead. No doubt?
No, ma'am.
Then I move to the next topic. Okay. 1 second. Give me 1 second. Huh? Okay. Now, this was the pigeonhole principle. Up to here, your functions is over. Functions is over. It doesn't mean that your module is over. If you remember, this module was having 2 terms, functions and relations. So around 40% is over. Now 60% is relations. Although when we started this module, we started with the relations only. So just tell me quickly, what's the difference between relation and functions? This I have described. Just tell me quickly. What is the difference between relations and functions? Friends? Okay, tell me.
Subset of a Cartesian product.
Yes. Huh? Sorry? Yeah, sorry, what you told? Come again?
And subset of a Cartesian product.
Yeah, correct. Subset of Cartesian product was the relations. Means there was no condition applied. Like in function, we have a condition that in a domain, each element must have image. And second condition, that one to many was not allowed. Okay, it can be 1 to 1 or it can be have many to 1, but 1 to many was not allowed. But if such kind of conditions are not there, you just take the relation between 2 elements, where first element is of domain and second element is of codomain. No condition is applied in the sense, might be domain element are not having any image, and might be one element is only having 3 or 4 images. So in such case, we call it relation. So there is a very big difference between relation and function. In fact, function is type of the relation with some conditions. So in fact, when I started, I gave the first introduction of relation. That's why actually few people, that's why take function relation first and then function, because of this thing only. Because after the relation only function came in existence. But actually that syllabus was little less, so I always prefer to take function earlier before then the relation. So relation was actually subset of order pair. So that means here relation you will be having in the form of order pair. Okay. The number of relations also I have told. For example, if you are having a relation from A to B, can you tell me how many number of relations possible will be?
Ma'am, 2.
Only 2. 2 raised to power m into n. This also I have told you the number of subsets. 2 raised to power m into n was the possible number of subsets, and relation is the subset only. So that's why possible number of relations is 2 raised to power m into n. Okay. Now we come to the properties. So what are the properties? Very important. Although might be you have already studied in your PUC. Reflexive, symmetric. What's the time? Can I do this? Yeah. Antisymmetric. And the fourth is transitive. These words are familiar or the completely strangers? Huh? What happened? You have heard of them or nowhere? This is
Yes,
first time.
ma'am.
Looking like aliens. Reflexive, as the name sounds. Reflexive means reflection of itself. So means first we will consider that some relation is there from A to A or A to B, you can say, but A to A. Then an element for all A belonging to A. Each element of A should be related to itself. Then we call the function as a reflexive. Okay. So here for all these properties, I will be considering A as 1, 2, 3, 4 simply. Okay. And here I will be defining the relation. So for example, if I write 1, 1, 1, 2, 2, 3, 3, 3. Tell me, is this reflexive? I only tell you now. This is not reflexive. Why? This is not reflexive? Because you see, 1, 1 is there. Means 1 is having relation with itself. A is always denoted with A is related to A. Or otherwise, if I'm writing A R B, so that means A is having relation with B. Or like here, I can write this 1 R 2 like this. Okay. So here you can see they are telling that each element should have its own image. So if 1 is there, should have image 1. It's there. But 2 should also have 2, 2. It's there. Can you see 2, 2? No. Hence, it's not reflexive. For 2 be a reflexive, 3, 3 is there, but 2, 2 and 4, 4 must be here. So that time it is called reflexive relation. Understood? The element should be related to itself for reflexive. Okay. Symmetric. Definitions won't come, so that's why I'm just explaining. You should understand what are these. Definition would be available in notes, theory things. Symmetric. Everything's name sound only. Symmetric. Symmetric, we know that means same. On the left side should be equal to right side if you are saying. So symmetric, same, equal. So if A is related to B, B must be related to A. For all A, B belonging to A. Okay, so in this set only, for example, if you see, if I'm writing 1, 1, 1, 2, 1, 3, 3, 4. In this case, this is not symmetric. For to be symmetric, if 1, 2 is there, 2, 1 must be there. If 1, 3 is here, 3, 1 must be here. If 3, 4 is there, 4, 3. Now it's a symmetry. Okay, understood? Antisymmetric means anti, that's the word sound, anti. just opposite. So if A is related to B, then B must not be related to A. That time it is antisymmetric. So for example, if I'm writing R as 1, 1, 1, 2, 2, 1. So this is not antisymmetric. Why? Because 2, 1 is there. So if I remove this thing 2, 1 and I put like this, now this is antisymmetric. Okay, 1, 2 is there, but 2, 1 is not there. So antisymmetric, just opposite. So what you understand one thing, if a function is symmetric, can't be antisymmetric, and if it is antisymmetric, can't be symmetric. Means both together is not possible. Both are anti of each other. Clear? Now transitive. Transitive says if A is related to B, B is related to C, then A must be related to C. Means first to second, second to third, then first to third. For all A, B, C belonging to A. So for example, if I write 1, 2, 2, 3, 2, 1, 3, 2. This is not transitive. 5 is not transitive. What can I see? 1 to 2, 2 to 3. So it should be 1 to 3. 1 to 3 is not there. So it's not transitive. For being transitive, it should have 1, 3 as well. Now it's transitive. 1 to 2, 2 to 3, 1 to 3. Or otherwise 1 to, no, why I am taking 1 only? Not necessary you take 1 only. 2, 4, 4, 3. This is also transitive. 2 to 4, 4 to 3, then 2 to 3. Like this. Clear? Any doubt up to here? These are the properties of relation, very important properties. Okay. Now, based on these properties, different kinds of relations came in existence. What happened, students? Why you all are like completely silent? Getting bored? Okay, just let me give you 2 definitions, then I will leave. Okay. Be happy. Don't cry.
Thank you, ma'am.
You people are behaving like half dead. Shivansh ki awaaz gayi, and others are also not speaking.
We're there, ma'am. We're there.
Well, there, but you are not speaking anything, na? So I thought.
No, ma'am. We are speaking, ma'am.
Okay, then fine. Okay. So these were the properties. So on based of those properties, types of relations came. Not much, just 2. So this is equivalence relations. Equivalence relation means the relation which is satisfying 3 properties: reflexive, symmetric, and transitive. Then a function is called equivalence relation. Means the question would be, in the next session I will take, don't worry, I'm not taking now. The question would be, show that any relation they will give you, and then show that it is equivalence relation. Or otherwise, check whether the relation is equivalence or not. So in that case, you need to check whether the relation is reflexive, symmetric, or transitive or not. If any of the one condition is not satisfied, we say that the relation is not equivalence relation. Understood? These 3 conditions must be satisfied for being equivalence relation. Okay. These things all of you should remember. In the next lecture, I won't repeat them again. You forget always. Now next turn, same came partially. Not partially, actually partial only. Partial ordered relations. In this is also same kind. Difference is only in place of symmetric, it should be antisymmetric. So reflexive, 3 properties should be satisfied: reflexive, antisymmetric, and transitive. So any relation satisfying these 3 conditions, reflexive, antisymmetric, transitive, is called partially ordered relations. Okay, so the next will be the problems based on those only equivalence relations. I am going to take the problems in first section. We have done those problems. In yours, I will start on Monday. Okay. So you need to remember, I will start directly what are the equivalence relation, and then only we will start. We will check whether the given relation is satisfying these properties or not. If satisfying, then only we'll say this is equivalence relation. Okay. Any doubt till here of today's session? I wrap up. I am also getting bored actually of teaching.
Ma'am, anti-symmetric, can you explain once more?
Yeah, sure. 1 second. Huh? I have closed it. Anti-symmetric means, see, first, for being anti-symmetric, you should understand what is symmetric. Symmetric is like if I am writing 2, 3, then 3, 2 must be there. Okay. Opposite should be there. A, B is there, then B, A must be there. If I am writing 4, 2, then 2, 4 must be there. But if it is anti-symmetric, then the condition is opposite must not be there. So means if I'm writing 2, 3, then 3, 2 can't belong here for being anti-symmetric. If 3, 2 is belonging, then we say it is not anti-symmetric. So for being anti-symmetric, 3, 2 must not be there. Anything else can be there like 3, 4, 4, 4, fine. But 3, 2 must not be there. 3, 4 is there, then 4, 3 must not be there. So you see here, 2, 3 is there, but 3, 2 not. 3, 4 is there, but 4, 3 is not. 4, 4 is there. So that's why this is anti-symmetric. 1, 4, 2, 4, 2, 3, or 3, 4, or 4, 1. Now you tell me, this is anti-symmetric? This thing can tell me. Just observe all 5 order pair and tell me, is this anti-symmetric?
Ma'am, it is symmetric.
It is symmetric?
1, 4 is there and 4, 1 is also there. No?
So that's why it's not anti-symmetric. But who told if anti-symmetric is not there, then it would be symmetric? It is neither symmetric nor anti-symmetric. Neither case. There is a possibility. See, these are the property, reflexive, symmetric, transitive. It's a possibility that any relation is not satisfying any of the property, right? So this example, what I have written, is not neither symmetric nor anti-symmetric. Why? See, first 1, 4 is 1, 4, 4, 1 is there. You got it correct. Because of this is not anti-symmetric. Because 1, 4 is there, simultaneously 4, 1 is there. So it is not anti-symmetric. But if 2, 4 is there, 4, 2 must have been there for being symmetric. So 4, 2 is, can you see 4, 2? Can you see 3, 2? Can you see 4, 3? So it is neither symmetric nor anti-symmetric. Clear now?
Yes, ma'am.
So it's not necessary that one must be there. There is a possibility that both are not there. But yeah, both simultaneously can't be there. Either one of them would be there or both would be absent. Okay? Clear now, Soumya? Anything
Yes,
else?
ma'am.
Anything
No,
else, others? Okay. Then I wrap up the session. I take the attendance. Nitya Pratashni? Pavitra Hegde?
Present, ma'am.
Pooja KS?
Present, ma'am.
Pooja R? Pooja Shri?
She's present,
Ma'am,
ma'am.
Nitya Prakashin is present, ma'am. She got disconnected, it seems.
Okay. Prajwal? Pramod?
Ma'am, Pooja R is present.
Pooja R, first from your Gmail account, remove that setting, automated send that mail. Whenever I send you the request to attend the class, joining the link, I get a reply back from there. Nothing, dot, 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 3 dots. Please remove that. Dot, dot, dot means another thing. You are abusing me in something. What you don't want, you can't speak that, you people put dot, dot, dot. So please remove that, okay? Prajwal was absent. Pramod?
Present, ma'am.
Enough? Pritam?
Present, ma'am.
Hemant?
Present, ma'am.
Raghavendra?
Present, ma'am.
Ragini?
Present, ma'am.
Ashwin? Rekha? Riya?
Ma'am, Rashmi.
Why you are not telling? Ria, Rizwan,
Present.
Rohan,
Rekha is present. She just got disconnected.
Rohan S, Rohit,
Ma'am, Rohan is present, ma'am. He got disconnected.
Rohit, Hemant Arjun,
Present, ma'am.
Sai Karan, Sakshi,
Present, ma'am.
Samar Pratap,
Hi, sir.
Samar,
Present,
Soumya,
ma'am.
Present, ma'am.
Present, ma'am.
Present,
Sanjay.
ma'am.
See, now how you will walk up. When I will take slowly, you are like, okay, 10 minutes will think. Now I should speak. What is this? Sankirti, quickly tell. Don't waste the time in attendance. Satvik,
Present, ma'am.
choosing the step, who had left the message. Satish, Saurabh,
Present, ma'am. Ma'am, Satish present.
Saurabh, Prashant,
Present, ma'am.
Sonam,
She's present, ma'am.
Somali, Shivansh, Shraddha,
Shivansh is present, no ma'am.
Shraddha present, ma'am.
Lakshmi,
Present, ma'am.
Subhash, Shweta,
Ma'am, she left message, ma'am.
okay, Shweta,
She left message, ma'am.
Trisha,
Ma'am, Shraddha present, ma'am.
Susan,
Present, ma'am.
Shantu, Sujay,
Sujay, present, ma'am.
Kanya, Sarup,
Present, ma'am.
Sayyid,
Present, ma'am.
Sahana,
Present, ma'am.
Tanvi, Udakiran, Rizwa,
She put message, ma'am. Misbah.
okay, what is Anusha,
Present, ma'am.
Bharat,
Present, ma'am.
Sanjeev,
Present, ma'am.
Viklam,
Present.
Yes, ma'am.
Vaishnavi,
Present, ma'am.
Singh, Susan, sorry, Yash, Susan,
Present, ma'am.
Yash. Susan, actually, I had given you work now. Whoever is giving the message, leaving the message, please tell me, okay? Yashwant,
Yes, ma'am.
Yashwant,
Present, ma'am.
Yatish,
Yatish present, ma'am.
Rita,
Rekha got disconnected, ma'am.
okay. This was the Yasin Ahmad. I think Yasin Ahmad was also present. Yasin, Manjunath,
Present, ma'am.
Hey Deepak, Sushma,
Present, ma'am.
Rohan,
Present, ma'am.
Javed,
Present, ma'am.
Amrav, absent. Yadunandan, absent. Harini,
Present, ma'am.
Amrit Kumar Jha,
Present, ma'am.
Mandeep. Okay, students.
Ma'am,
Ma'am, Shilpa
Sankirti
present,
also present. She put it on chat now, ma'am.
That's why I was asking that moment only. Please tell me. Sankirti,
Now she
Sankirti, I think I had given.
Ma'am, Shilpa also, ma'am.
Sankirti, okay, not given. Shilpa, huh?
Yes, ma'am.
Okay. Anyone else?
Shweta, ma'am. Ma'am, Shweta is present.
You gave Shweta, ma'am. I told Shweta.
Shweta, I gave. Okay. Chalo.
Thank you, ma'am.
Okay. I'll take on Monday. See you. Chalo. Bye.